On which of the following games would you bet your money on? Option A, rolling at least 1 6 with 6 dice. Option B, rolling at least 2 6s with 12 dice. Or option C, rolling at least 3 6s with 18 dice. I personally found this question more tricky than expected. Not in the sense that the solution is very hard to find in the end, but rather that it's hard to tell directly which one is the best without doing any calculations. So, why is this question problematic in the first place? To figure that out, consider the event that rolling a die gives you a 6. This is a Bernoulli random variable with success probability 1 over 6, such that in total we have 18 Bernoulli random variables, 1 for each die. Then, since these are IID and the expectation is linear, whenever we throw k dice, we get that the expected number of 6s is given by k over 6. So for option A we actually expect to see 1 6, for option B we expect to see 2 6s, and for option C we expect to see 3. And at that point, some people might conclude that all 3 options are equally good. And some others might conclude now that the probability for A, B and C is actually 1/2. If you're one of them, then stay tuned. We'll find out what's going wrong with that reasoning and how we actually can figure out which option is best. And with that, welcome back to Probably Optimal. Nice that you're here, and without too much talk, let's dive right into. So, to figure out which option is best, we have to recall that the sum of Bernoulli random variables gives a binomially distributed random variable, as shown here below for p equals to 1/2. While this binomial distribution is symmetric, for other values of the success probability, the binomial distribution is actually asymmetric. That means that the mass is not equally distributed around the mean. So, for larger values of the success probability, this distribution puts even more mass onto larger values, and for smaller values of the success probability, it puts even more mass onto smaller values. And additionally, for all 3 options, if we throw fewer dice, the total number of options decreases, such that each individual option gets more likely, simply because the total mass of one gets distributed across fewer values. So these 2 considerations now hint at the fact that option A is preferable. But is this actually true? To find that out, let's simply compute the probability for A, B or C to win. For C to win, we need to roll at least 3 6s with 18 dice. So if we consider the binomial distribution corresponding to 18 dice, we have to sum all the values of the probability mass function corresponding to 3 or more 6s. This gives that option C wins with a probability of 59.7%. Similarly, for option B to win, we need to roll at least 2 6s with 12 dice. If we again consider the binomial distribution, just for 12 dice this time, we need to sum all the values of the probability mass function corresponding to 2 or more 6s. This gives that option B wins with a probability of 61.9%. And finally, we can play the same game with option A to conclude that option A actually wins with a probability of 66.5%. Therefore, if you need to choose one of these games, do yourself a favor and choose option A. So that's it for the video. I hope you liked it and you could learn something from it, and thanks for watching.